We're going through section 2.4 and 2.5, looking at linear functions and equations of lines. We're here at example 6, and we need to find the equation of a line through a given pair of points. Maybe you've heard before that 2 points determine a line. That means there's only one way to draw a line through 2 given points. And so what is that particular line for example, for the points at -4, 8 and 2, -3. So this is an important problem, and one that's often on the exam. And the first thing that we want to do to answer this question is we want to find the slope. So this is really a two-step process. One, find the slope. And then 2 is going to be to plug into point slope form. So first things first, slope is y2 minus y1 over x2 minus x1. Might be good just to take the time to label the numbers. x1, y1, x2, y2. We don't want to get confused when we're plugging them all into the formula. So we have -3 minus 8 divided by 2 minus -4. And so that would be -11 over 6. And so there's our slope. And so now we can take that slope and either one of the 2 points and plug into point slope form, just like we did in the previous video. And so let's see here. Point slope form says y minus y1 is equal to m times x minus x1. And so we'll have y minus y1 is 8, and then m is -11 over 6, x minus x1 minus -4. There we go. And so then we can just go ahead and simplify that. We can just solve for y. And so we'll have y minus 8 is equal to -11 over 6 times x. And then this is a +4 times -11 over 6. So that should get us -22 over 3. And then we can add 8 to both sides. 8 is the same as 24 over 3. So when you add that to the -22 over 3, you get +2/3. And there's your answer. You could go on one more step and write that in standard form, just the way we learned to do in the previous video. I won't take the time for that right now. Here's another problem, example 6b. It's very similar. This would be a great time to pause the video and try to do this problem for yourself. Okay, so once again, we're going to find the slope of the line first and then plug into point slope form. So slope is going to be -6 minus 4, y2 minus y1 over 2 minus -2. That's x2 minus x1. That's going to get us -10 over +4, which is going to simplify to -5/2. And then when we plug into point slope form, we get y minus y1, which is 4, is equal to the slope, negative 5 halves, times x minus x1, which is negative 2. There's our equation. We just need to simplify a little bit. We get y minus 4 is equal to negative 5 halves, and then negative 5. And so when we add 4 to both sides, then the numbers come out nice this time. We get y equals negative 5 halves x minus 1. And we're done. Okay, well, let's go on and let's do this again. In part C, we have negative 3, 8, and 5, 8. And so this one is going to come out a little bit different. Oh, one other thing I wanted to say. You know, when we plugged into point slope form, we used the first point, negative 2 and 4, negative 2 and 4. But we could have just as well used the second point, the other point, and the answer would have come out exactly the same. And that would be a good exercise for you to verify, to plug in 2, negative 6 instead of negative 2, 4 into the point slope form and see that the answer doesn't change. Okay, in part C, there's just a little wrinkle in it. Maybe you can see it already. If not, we'll see it together here in just a second. When we get the slope, we're going to do 8 minus 8 over 5 minus negative 3. And so that's 0 over 8, which is 0. So the little wrinkle is the slope is 0. And you could actually see that because the y values are the same for the 2 points. So if you think about that, the y value is the height of the point on the graph, and so if they have the same height, then maybe you can visualize a horizontal line through those 2 points, and of course the slope has to be 0 through that horizontal line, and that's exactly what we found. So the slope is 0. We should stop right here and say, hey, that's a horizontal line. That's one of those special cases that we talked about in a previous video as well. And so then remember how we write the equation of a horizontal line. We just write y equals a constant. And so what would the constant be in this case? It would be the y value. And so the y value for each of these points is 8. And so our answer is y is equal to 8. If we didn't see that, or if you would just like to try to work the problem the way we worked the previous one, in the previous problem, we actually took the slope and the point and plugged into point slope form. Y minus y1 equals m times x minus x1. And so that would work too. It's just a little bit unnecessary. You'd have y minus 8 is equal to 0 times x minus negative 3. And then, of course, 0 times anything is 0. So we have y minus 8 equals 0. And when we add 8 to both sides, then we still get the same answer, y equals 8. Okay. For the last one, you can see that this time the x coordinates are the same. Do you remember what that is tells us about the line? that tells us that the line must be vertical, and the slope is undefined. And the equation of the line is x equals a constant. In this case, the constant is -4. And we're already done. Now, just to go back for just a moment, we could have used the slope formula. We would have gotten 10 minus -10 over -4 minus -4. That would be 20 over 0, which of course is undefined. And so then, at that point, we can't plug into point slope form because we don't have a slope. There is no slope for this line. This line is vertical. So then we have to jump over here and just say the equation is x equals a constant. That's the constant, -4, and so we're done. We can write our answer, x equals -4. Okay, the horizontal and vertical lines are special cases. We need to understand their properties, and we need to understand how to recognize them given 2 points or given the equation of a line, of a horizontal or vertical line.